Hello, my name is Mike Usrey, and today I'm going to be talking about some dirty parts, some clean parts, and why you might want to change them out. No, in all seriousness, we're going to be talking about ball joints. Got a lot of different parts here in front of me, but they all have one thing in common, and that's that they all have some kind of ball joint in their usage and how they move around, what they do, what they're used for in the car. I want to talk about all of this kind of stuff, why you might want to be looking at them more closely if you've been neglecting them, what kind of maintenance they require, and how to know when it's time to change them out. So let's go ahead and get started with what the heck are ball joints? It's a pretty simple thing. A lot of you probably have heard the word, you've probably even seen ball joints before. Just to give you a very, very basic example of a ball joint, this is actually a tie rod end for an NA or NB Miata. But this guy right here, this is a ball joint. And it's a ball joint because it's a joint with a ball, but it is flexible, it moves around, and it does this by being able to move in several different motions on an XY axis, but it also can rotate. It does have a limited amount of travel for which direction it can go, and we'll talk a little bit more about kind of some interesting use cases of when you might have more in one direction but not the other. But in general, these are metal objects that they allow you to put together two pieces that need to be able to rotate or move or flex. But you wouldn't want them to actually come apart from each other. They just need to move relative to each other. These are very common components that you'd find in suspension systems. All Miatas have ball joints in the front suspension. NCs and NDs even have these in the back, in the rear suspension. NA owners, as a bonus thing that's not a suspension, can anybody guess what ball joint do you have that's not part of the suspension? Does anybody in the crowd, peanut gallery, know? The ball joint that's not in your suspension on NAs is actually part of your headlight assembly. So your headlights go up and down, and they actually have little, basically ball joints. It's kind of more like a ball and socket on those, but it's plastic pieces, and it allows pieces to move together relative to each other and rotate, but it's not necessarily part of the suspension. Today, I'm going to be talking about mostly ball joints in relation to suspension because that's where they're most prevalent across all four generations. I do have mostly NA and NB parts in front of me, but as you can see, NC parts, and again, there are parts on NDs that feature ball joints. They all work pretty much the same though. As I mentioned, ball joints, they're very simple, but I did want to give everyone a little bit more of a kind of inside view. So here's one that I cut open yesterday. They are just a few pieces. Basically, you have this boot on here, which fortunately I've got this one. Oop. If I can hold it without falling apart there. There we go. I just got that. Comes right off since I've cut it mostly in half. You can see that it has a housing and then the actual ball joint, which is almost a complete sphere, but of course has this stud at the top that we'll talk more about in a second. And as I remove it, we have a plastic liner. I'm not quite sure exactly what this one is in particular, but usually these plastic liners will be made out of nylon or Teflon or some kind of a really slick but still very hard and durable plastic. And then at the bottom here, there's actually a little kind of trap door. This is basically when these guys are built, whenever the manufacturer is making these, this housing of course would be whole. Everything gets pressed in from the bottom to be assembled because it's all complete. And then this would be a whole circle, but it'd be pressed in place, and then this lip would actually be swaged around it to retain it, so that way your ball joint doesn't fall out after you have everything put together. So pretty straightforward. The sharp-eyed among you would notice that these are relatively clean parts. They don't have any grease. That's a big component with ball joints. So inside ball joints, besides these parts that I just shown you here, something that helps keep them able to move and rotate without coming or basically wearing down or having issues getting sloppy, which we'll talk about in a second, is having lots of grease in them. This is a replacement ball joint that whenever you buy replacement ball joints, generally, oops, they come pre-greased. And this one, you can just see, it's kind of dark colored grease, so apologize if you can't see it great, but they'll come with grease that's basically all around that ball joint. And then also, typically, it'll be packed into that plastic liner top and bottom as well, so that way it has a nice reserve of grease, so that way when it moves around, it's able to move freely without binding. So, clean up my mess a little bit. There we go. In short, ball joints are just a few pieces, but they have a very important job. They do keep suspension parts together, but allow them to move. Most notably, in your front suspension for all Miatas, you're going to have a lower ball joint, you'll have an upper ball joint, and then you'll have your knuckle with your brake rotor and then your wheel attached. But this way, you can have that knuckle able to rotate and move around. Also, when your suspension is going up and down with travel, that allows movement, so that way that knuckle can stay in the same relative position, still be connected to the top and bottom or upper and lower control arms, but still be able to have that range of movement for being able to turn and rotate and also go up and down with the change of suspension. So they're very handy mechanical devices to have for things like this. They're also very tough. Another feature of ball joints that I didn't really touch on before is that they have the threaded portion at the top, of course, but they're tapered. Generally speaking, all the Miata ones are tapered. This taper, it's smaller at the top, wider at the bottom, but it fits into part of the knuckle that has actually a tapered bore. And that tapered bore basically sits on there, and when you tighten down the nut to be able to hold it in place, basically that forces everything together and squishes or clamps the knuckle onto this taper. That way it's got nowhere to go. The other thing that's very common on these guys is the use of a castellated nut. And why would you want to use a castellated nut? So you can see that it looks just like a regular nut, except for it has these spaces between all of the corners, basically. On these guys, typically, they also will have a little hole through them, the top of the threads here, so that way you can have a little pin that goes through. Now this is not correct, it's too low, but in practice, this would actually go through the little gaps, or gaps in the teeth, you could say, of the castellated nut, and then you would bend this around, and that locks it in place. So that way, even if something were to happen where this nut were to get vibrated loose a little bit, it can't back off. This can't pop out of the suspension. Your wheel can't go flying off into the wild blue yonder because it's actually being retained by several different locking features. The other thing about castellated nuts is that since we're dealing with a taper and we're having that basically force the taper to wedge itself into the knuckle, all this is doing is keeping that relative tension pretty tight. It doesn't have to be exact. There's always going to be torque specs for these guys, of course, but it's mostly about the taper engagement when it fits into the knuckle or control arm or whatever it's being pressed into. But castellated nuts, because they have that extra locking feature, that's really the whole reason, is it keeps everything from coming apart if the worst were to happen and this nut were to loosen up. So very handy little guys. You don't see them a lot of places except for generally on ball joints of this nature. But yeah, that's a pretty typical thing. Castellated nuts are pretty useful for this. Okay, let's see. I think that we've kind of covered the basic anatomy of a ball joint, how it's normally going to be functioning in the suspension or keeping components together. So let's talk about what they look like when they go bad. So as I mentioned with this example that I've cut apart, you can see that it rotates around and it's supposed to have grease in here too. And that's what keeps everything nice and happy and kosher. In a fresh ball joint, let's see, here's a brand new one. In a fresh ball joint, all the tolerances are pretty tight. It's enough to allow it to move around, but it's not just going to flop. So to be able to move this, I actually have to apply a bit of pressure to get it to move. and you can see it moves around, you know, and I could rotate it if I had something to hold it with. But this thing can move around, but it's not flopping everywhere. If you had an instance where this was worn down, either the ball or your liner or something like that, and you had a lot of play, and basically, I'll just take that out of there. If this were able to kind of either move around in this direction, or if it had a lot of side-to-side play or anything like that, that ball joint would still hold everything together, but you'd have a lot of play in that. One, it'd be noisy. You can actually hear that clunky noise as it moves around, generally speaking, when it's bad enough. Also, when that happens, you can get some exciting dynamic alignment numbers. And what I mean by that is that you can actually, depending on the application, you can get your wheels moving in ways that they are not supposed to, because basically, instead of just rotating at a single point, you know, at this single point, if this is loose and able to move around, then that point, that pivot point, is now wherever it's moving around and being forced to. To show you an example of what it looks like when you have a bad ball joint, let's actually step over here to, we have a NB up on the lift, and we actually stole a really bad tie rod end. And this guy, it's really, really wobbly. And I do have it in there, so it's actually, the stud is tight. The shaft you can see here, but even just giving it a little bit of pressure here, you can see the body, the housing is actually moving up and down. So that's really, really loose. This is a pretty dramatic example, but I can actually take the brake and knuckle assembly and I can move it around like this. Can you hear that? But see how much it's wiggling around. At the hub, well, actually, you know, think of it at the tires where you're going to have even more movement. This is probably somewhere around 3/16 a quarter inch of movement in rotation just because of this. This is a really, really worn example, but we wanted to be able to showcase something you could see on camera. This would really, really mess up your toe. So like right now, the steering is actually locked on this car. So nothing is moving except for this ball joint. But say if you were driving down the road and you had this bad ball joint on one side or even both, what you might experience is that you're driving down the road and going straight, you might not notice it. You turn one direction, doesn't really feel weird. You turn the other direction, like in this case, then you're going to be, actually you'd be turning right and you'd be loading the car. It would want to keep going left. You can actually get basically forces that want to pull the front of the tires apart. And you could be turning into that corner and it feels fine. And then all of a sudden goes, ugh. You kind of feel it shift a little bit and your steering wheel actually might change a little bit, even though you didn't change the input. You go around the corner, you finish, you straighten back out. And now your steering wheel, if it was level or straight before, now it's kind of like a little bit cockeyed. Then you go around another corner the other direction and you feel it kind of shift a little bit and you come out on the other side, you straighten up and then your wheel is straight again. That's because your ball joint is that worn. You're actually having or experiencing dynamic toe, which is a bad thing, or at least in this kind of case. There are cars that have very fancy suspension strokes that they do a lot of things with camber, caster, and even toe. But in the case of unexpected dynamic toe or unexpected dynamic camber, that is something that, generally speaking, especially with toe, is going to create an issue for consistency of driving. Also, you know, camber is not as bad, but you're still going to feel it. You usually also can hear it as you load up the car one direction versus the other. You can hear it pop. And so that's an indicator that you likely have something going around or going on. To double check, you can do exactly what I did. Like in this case, since it's a tie rod end, basically you don't even have to take off the wheel and tire, but if you were to grab it and push it back and forth on the tire when it's up in the air like this, you would probably be able to feel this, if not see it. It may not be this bad, but same thing with your upper and lower ball joints. If those are bad, generally it's not as easy to test it going left and right, but if you were to grab top and bottom and push in and out top and bottom, that's when you would usually notice if your upper or lower ball joints are starting to wear out and get wobbly. That's usually the direction that you can tell is going on there. I will note that you can get some false positives there. If you have a wheel bearing that's starting to go, you can also get a lot of movement in any of those directions if your wheel bearing is really wobbly. But needless to say, if you got any kind of wobble in your axle nut, axle hub, knuckle, wheel assembly, you have a problem. Whether it be ball joints or wheel bearings, you probably need to dive in a little deeper and look to see what's failed. But this is a bad application, or a really bad ball joint to show you a dramatic reenactment of what it would look like. So all ball joints can fail in that manner. Basically, they get yucky, they get wobbly, they're all worn out. What causes this to happen though? Generally speaking, the number one cause is going to be boots that have ripped open. So this is a lower ball joint. This guy, you can see it's got a big comical cartoon mouth rip in it. And as this moves around, you can see some directions it's wide open, other directions it's maybe not, and you can't really see it. It's not open so much, but this is a car. It's moving up and down, you're turning the wheels. This is gonna be doing all kinds of stuff all the time. The problem is that when your boot is torn like this, it's able to get dust, debris, water, all kinds of yuck in here. And because these components are designed to be in a closed atmosphere and have relatively tight tolerances for being able to rotate, move around without actually having slop, when you get little pieces of grit or sand or even water down in there and get rust, then essentially you have bits of sandpaper that are just grinding away at the ball joint, at the liner. If it gets bad enough and you wear through that, of course, then, into the housing, but that's what creates the slop. You're essentially grinding away at the components that need to be held together tightly. So if you see a ball joint boot like this that is all kind of crazy, smiley, maniac, rip open like this, you should at least be inspecting this to replace the boot, if not potentially replacing the entire unit as a whole. Over time, even if your boot is in good shape, like this one's a used one, but the boot is in mostly good shape, they do loosen up, they do wear down. Grease is not a impenetrable, super zero friction material. It's very low friction, but it's not zero. So over time, this starts to get a little bit looser. Actually, that one's not even bad. Here, this one's actually really loose. So this one, I pulled the boot up so you can see a little bit more underneath, but see how I can just use one finger and it just kind of flops around. So when they get this loose, they're starting to get more tolerance between the ball joint and the housing. So this one, boot was fine, but it had a lot of miles on it. They do wear down over time. Eventually, all ball joints do need to be replaced. They're wear items. Similar to brake pads, rotors, all of that kind of stuff. Over time, they do wear down. So this one, just since I'm holding it, and I mentioned it earlier, it does have kind of a goofy housing, and not all ball joints are the same. This one, if you are in the know, is an NC upper control arm. And look how it has this extra kind of slot there in the front and at the bottom. So this allows the ball joint to be able to move more freely in this axis. You actually get more movement compared to if I were to go this way, it's much more limited. And this is designed such that, as an upper control arm, as it's going up and down with the suspension, you have a wider range of movement. But since this is a knuckle here, it doesn't really need much movement in this axis. It just needs to be able to rotate, which is also, of course, very good with a ball joint. But they do have different shapes sometimes, just depends on the application for the housing. I will also point out, since this is an NC control arm, there are a lot of them that are not designed to be serviceable. This one in particular, it doesn't have any mechanism that allows you to replace it. In a lot of control arms or other applications, you can remove a small part of it, that's just like the ball joint and a little bit that attaches to the control arm. Or in the case of, like, here is a upper control arm ball joint for an NA/NB. This guy has splines all the way around here, and it's actually pressed into the control arm, and that's how it's retained. You can press it out and press a new one in. We'll show that in just a little bit. But this one is actually machined into this control arm. It's a cast aluminum arm, and this whole body is machined. The only thing that's not part of the arm is the ball joint stud, and then the cap at the bottom that's swedged into place after they install that ball joint. So sometimes you just have to replace the entire component, in this case, an upper control arm. Speaking of replacements, you can do that oftentimes, but in cases of like NC upper control arms like that, and D upper control arms, a lot of the multi-link rear control arms in NCs and NDs, and if you ask Mazda, they'll tell you that NA and NB upper control arms also should be replaced as an assembly rather than replacing as a ball joint. Mostly that's just because how they're sold with NAs and NBs, because, you know, there are aftermarket brands that do offer upper ball joints. But at least as of right now, I don't know of any brands that sell anything that you could pull out this ball joint and you know, try to reuse the arm. It's just not practical for most people in their garages at home. So usually the answer is break out your credit card and pay Mazda for a nice shiny new arm. Usually comes with brand new bushings installed in it, and of course, new ball joints. So be aware, depending on what the application is, you may or may not be able to service it directly as just the ball joint. Oh, good question. So I'm glad you asked. The question is, how does a Heim joint, a rose joint, or I'm trying to think, there's a few names for them, basically a spherical joint, compare to a ball joint when it comes to their use case, longevity, application, that kind of stuff? A very popular item to use ball joints or Heim joints or rose joints, whatever, any of those options are end links. So these are a pair of our end links. We've got them for all generations. This particular generation is a NA, so we have a bushing style link end and then a ball joint end. It's actually common for Mazda, their stock end links use ball joints on everything except for the NAs, that they use these open eyelet style or bushing style end links. But you can also get aftermarket end links that have Heim joints or spherical joints on either end. Those are really good in that they offer a wide range of motion. So like a ball joint, well here, let me get one that's a little easier to move. Like a ball joint, they do have a range of motion that they're able to not only go this way, but go this way. They can rotate, you know, they've got a lot of motion that way. But because they are built into a housing, they're a little bit slimmer, so you can usually fit them into tighter spaces. You do need to use a bolt and a nut generally for them, but you can usually get them a little bit skinnier as an assembly. They usually have actually a slightly greater range of motion than a lot of ball joints, so some of them might get a few, you know, an extra 5, 10, 15 degrees of motion. Just depends on the quality of the spherical joint. So yeah, they're really handy. They're very popular. They're also not very expensive to make a lot of times. The downside though is that spherical joints, unlike ball joints like this that have boots on them, you could think of them, well, you could think of them like a ball joint without a boot. So they allow all of that movement, but they're totally open to the elements. They're very popular for use on race cars or applications where you need quick, easy access and you need a lot of range of motion and control and adjustability, but they don't generally have any method for keeping dust and debris out. And they have moving components, basically kind of like an eyeball with a hole drilled all the way through it, and that's where the bolt passes through, and that has to be able to rotate and pivot. So since it's open to the elements, if you are driving around on any kind of a even partially dusty road, debris gets in there, that sandpaper effect is eventually going to wear them down over time, and that's going to happen quicker than such as a ball joint that has a boot to protect it. So that's one of the main differences, at least for us. It's mostly a practical difference, or at least an application difference. So we tend to use ball joints on a lot of stuff like end links because they're a little bit more OE application and longevity compared to a spherical joint setup. But they each have their own application, and they can be ideal in different instances. Good question. Oh, I didn't talk about maintenance as far as like we know what to look for, why they get bad, that kind of thing. But is there like a maintenance schedule for when you should check your ball joints? Yes and no. A lot of it is going to be dependent upon if you let them get this bad to where the boots are ripped open. They do have you could say they do have a maintenance schedule. It probably depends on which manufacturer you're talking to. Most ball joints are pretty long-lived. You know, actually, this ball joint we just pulled off of Logan's car, and it has how many miles on it, Logan? 140. 140,000. So, you know, you can see there is a little rip here, so it's starting, but it's not even that bad. I think Logan's car has probably lived a relatively easygoing life. It's not been a track car. If you really track your car hard, if you're going off-road, if you're basically utilizing and moving the suspension a lot, you probably need to check more often than if it's mostly just a pavement cruiser. You know, this is something that you go have fun on Sunday afternoons, go drive in the mountains, whatever. But generally speaking, I would recommend that you check your ball joints anytime you're under the car, at least a precursory glance. I usually look mine over, just, you know, oil change, okay, yep. No obvious rips, it's probably okay. As far as an in-depth look to actually test them, like what we did on the car where I was moving stuff around, you might even get a pry bar out and use a pry bar just to make sure that you're able to move and actuate ball joints to see if they have any movement in them. Let's say 30 to 60,000 miles, somewhere in that ballpark. You know, so whenever you're doing a transmission or differential fluid flush or something along those lines, you can work it in with other maintenance that you already have the car up in the air. So that way you're kind of killing two birds with one stone as far as your maintenance is required. So yeah, basically they're one of those things I recommend that you just keep an eye on. Try not to forget about them, even though it is easy to forget about ball joints. Oh, another suggestion that I got about this question, since we got it in advance, is that if you know you're going in for an alignment, you should either ask the alignment guy to check it or check it in advance. Because if you do have a bad ball joint and you go in for an alignment and it's so bad, like on the car, that it's actually bouncing around inside the housing, then you might get an alignment that the alignment guy may not catch it. And then your alignment has, you know, maybe good numbers whenever the ball joint is moved over to the outside position, and then it changes by 1.5 degrees when it flips over or kind of shifts over to the other side of the housing because it's that worn out. So even after you fix it, it may or may not be a good alignment because who knows, you know, which position it was lined in when it was on the rack. So check that stuff out, or ask your alignment guy to check it out when it's on the rack, because that will potentially cause you to go back for a second alignment, and it may be something you have to pay for. So let's talk about some non-stock options for ball joints. So talked about some of the stock stuff over here. Let's move over to this side of the table. As I mentioned, there are ball joint options for a few of the different applications here, and just to cover a few of them, we do have replacement upper ball joints for NA specifically. They are different from NB in that their taper and lengths are a little bit different. This one over here is from an NB. You can actually see the taper, how it ends up much higher than this NA version. So they aren't directly interchangeable. There are folks who will use washers to stack up on the NB style to get it to achieve the same effect as the NA. You could make that work. I wouldn't necessarily recommend it unless you're in a bind and just need to get through a few days until you can get the correct part in. But they are different, so be aware. Make sure you order the correct version for your car. We don't actually carry an NB upper ball joint replacement at the moment. This one's from Moog. I think that there are a few others on the market out there for NB. I think V8 Roadsters might have an option that they do custom. But these guys are very handy because instead of replacing the entire upper control arm like what Mazda wants you to do, you can actually do this for quite a bit cheaper, especially if your control arms already have new bushings like poly or rubber performance bushings installed into them. And if you order a new control arm, it's going to come with new stock bushings installed in them, typically speaking. So if you don't want to redo pushing bushings in and out, you might consider doing a ball joint replacement like this instead. These guys do come with new boots, and What's important to note on upper ball joints or upper control arm ball joints for NAs and NBs is that they do also, besides the spline, they should have some kind of a locking ring that basically once it's installed, it gets locked in place and holds it, retains it from the top and bottom. There's a lip here that retains it whenever it gets pressed through from the top, but this should also have a ring on the bottom to retain it so that way it's not able to pop out. Once you press a ball joint out of a control arm and press a new one in, the metal of the control arm itself actually is kind of loosened. So it does need a retaining function of some method. Some ball joints I've seen actually also have places where you're supposed to dot like 3 or 4 little tack welds along the top to the control arm itself. So make sure that either it has some kind of snap ring or it's intended to be welded, something like that. Sorry, I did intend to talk about it and I forgot. Thank you. So the question is about Zerk fittings, and this actually is a good example. Aftermarket ball joints will sometimes have Zerk fittings or grease fittings. This is something that only the aftermarket stuff, none of the factory stuff has any kind of points at which you can add grease. They're all totally sealed in the bottom. But for aftermarket ones that do have a grease Zerk, basically this can be serviced. So you can add grease to it. You need a grease gun, but those are pretty cheap. Every auto parts store everywhere has them. You can use regular chassis grease. Literally, that's what it says on the tub is chassis grease. And you can pump more grease in here. What'll happen is that as you have this installed in your control arm, boop, pretend my arm is a control arm, and you pump in more grease here, it will eventually start squishing grease out the top of the boot, and you'll know that you're actually starting to push more grease in here than what can be contained within the housing and in the boot. I feel like I should be Canadian when I say that. It just seems appropriate. Sorry. But when that happens, basically you're flushing out, hopefully, debris that might have gotten in around past the boot and into the grease on top, and you're replacing old grease at the bottom that may have basically aged out. It started to break down with new fresh grease that's just pushing its way out. So you do want to purge some of the old grease and hopefully debris out, and then usually I'll do kind of a little bit of a squish and that'll help squish a whole bunch of the old grease out as well. You don't want to have a ton of grease, basically just enough that it's resting in the bottom around the ball portion of the joint. Because if you put it back in there, just packed full of grease, as soon as you tighten it all down, it's going to squish everywhere. As soon as you go driving everywhere, it's going to squish even more. So a little bit goes a long way, but yeah, using it as a purge function is actually really helpful to prolong the life of your ball joint. Back to, here we go, the tie rod end. So again, for NAs and NBs, NCND owners, this really is more about the NAs and NBs because there are more serviceable and individually replaceable parts. But for NAs and NBs, you can get a regular tie rod end. This one is actually an R-package tie rod end, in that it's the same design. It threads in the same way on the end of your tie rod inner portion, but this taper is higher up, so it helps correct for bump steer if you have a lowered car. So if your car is lowered from stock, this is actually a really simple upgrade that's kind of also a maintenance item all in one. This is a really handy thing to do if you're doing other suspension bits like new shocks and springs or coilovers, something like that already. You're already got the car up in the air. This is an easy add-on to do at the same time. Likewise, for NAs and NBs, we have extended lower ball joints. I'm only going to talk about these a little bit. We probably could do a deep dive about these if we really wanted to. But similar to the tie rod ends, these guys are a replaceable unit. So just like the factory one over here, this crusty guy, it just bolts in place. Actually, I'll show you on the control arm itself. It's got one bolt up top here, and then it has a bolt and nut that hold it through this way. So it's real simple. You don't have to use a press or anything difficult, just hand tools, or if you got impact gun, works great. These extended lower ball joints though, they are a slightly different design, and you can maybe only barely make it out on camera, where this bolt hole where this is compared to the housing is closer together, whereas on this guy there's a little bit more room between the housing of the ball joint and that through hole. And basically what that does is it moves the lower point of your wheel further out to give you more negative camber. So this will actually swing your camber, available camber window out by 3 degrees. I will keep it short and say that if your alignment is good and you're happy with your numbers now, you don't really need this. But if you're racing or if you need to get more camber because you're wearing the outside of your tires more on the track than you are the inside, you probably need more camber, which means you might need one of these extended lower ball joints. If you have more questions about this, give us a call, send us an email. We'd be happy to walk you through it. But that's a handy feature. Again, if you're doing suspension upgrades and you need to replace stuff anyway, doing lower ball joints is really easy. As mentioned earlier with the end links, this one is actually applicable to all Miatas. These again are NA end links. But this is another popular one that, especially if your stock end links are worn out, if they're really crusty, these guys actually are pretty prone to rusting. So if you need to replace them while you're down there, if you're looking to get some end links that have adjustable length, so that way you can get your preload dialed out of your new suspension system, then these are a really handy way to do it. I'm showcasing these ones in particular for NAs because the difference in ball joint versus bushing. Now, NAs, you have to have the bushing side at least for the lower control arm because you have 2 tabs and a bolt that goes through it. And that's how it has to go into the lower control arm. But for the upper, when it goes through the end of your sway bar, it could be a bolt or it could be a ball joint. So we choose a ball joint since you have a little bit better range of motion. It's a little easier to install and better longevity overall. One of the benefits of actual like range of motion between the ball joint and the bushing, just to showcase, I've got a lot of motion, range of motion here. But with the bushing style, I have a comically large bolt just to kind of help showcase. But they are intended to move and flex, and you can see this one moving and flexing, but it does take a lot of effort, and it doesn't move quite as much unless you just really crank it. So they do a job, and they do a job relatively well. But pretty much any time you could change out these bushing style and all end links for a ball joint, it's a win. You get easier installation and better range of movement all around. Okay, other things, kind of, I guess, talking a little bit back about maintenance, but also just upgrades. We do sell quite a few boots to be able to replace your boot. And these guys, this is a factory boot to go over a factory upper ball joint. They basically have a little lip and they just slip on here. These guys are very straightforward. If you've never replaced a boot on a ball joint before, there are lots of ways to screw it up. And I will preface this by saying that if you haven't done it before, take your time. You need a tool. Usually you can get by with a piece of pipe or even a socket if it's the right size. Or there are special installer tools that basically you want something with a lip that's the same size as the lip on the boot. So that way, when it fits down on it, it actually presses down along the lip instead of along this portion, because this portion of the boot is really flexible, but the lip actually has metal in it that reinforces it. So pressing down on that, and you need a washer and a nut to press it down, but that's actually going to install it. If you have something that presses down on the soft rubber up here, you're going to rip the boot and then you're starting over. And I will let you know that Moog, if you get a Moog upper control arm ball joint, they don't sell these boots separately. So be extra careful if you get these guys. And I will shamelessly plug that we have an installer tool specifically for the Moog ball joint boots for that very reason. These are on our website. So if you want to make sure you don't mess it up, get a set of these installer tools. A question we do get asked about this installer tool is, does it work for the factory one? No, unfortunately. They are actually different sizes. So this would not press that in very well. So at the moment, we don't have an installer tool for any of the factory boots. If you think that's something that you would like us to make for you, would that be useful? Drop us a comment down below, because we do have a lot of these kinds of tools that were born out of necessity. So if it's something you think is handy, let us know. We might make it into a product going forward. So unless we have any questions that we want to cover right now, I'll go ahead and show how to replace a ball joint. We do have some. I kind of touched on it. So the question is, when might you buy a complete control arm versus a component like this, a ball joint that you can actually service yourself? A lot of it is what's available. And if you're able to buy a ball joint like this by itself and press it out, press a new one in, sweet. It's usually less expensive. You don't have to worry about what bushings you have pressed into the other ends of your control arm, because maybe you have some nice poly or, some new rubber bushings pressed in here. So if you're able to just replace the ball joint, that'll probably save you money and effort in the long run. But if you're not able to buy or service a ball joint at all, like NCs, and I think even NBs, I actually haven't looked at them that closely, then you may be forced into buying a complete control arm because that's all that's available to you. So just depends on application. The other thing that might sway your mind is that, say the car is relatively stock and you're just looking to replace components to get rid of a really, really bad ball joint that's knocking around. Maybe you don't have a press, maybe you don't have tools. The easy button is probably just to buy a new control arm with new bushings and new ball joint installed for you. So that way all you have to do is replace the entire arm. So, if you're looking for an easy button, that's also a very, very viable option. Good question. Do I have to get an alignment after replacing ball joints? So, no, technically. I would put a pretty big asterisk on that if you're not sure what the alignment was before and you think that your ball joint has been bad for a long time, then it's probably worth your while to go have the alignment done again. Because if an alignment was performed on the car whenever the ball joint had already been bad and is wobbling around, it's possible that your alignment was done with incorrect information. So if your wheels were, doing whatever they were because the ball joint was loose and floppy, that might be where your alignment was set. But if it's dynamic because you're driving around and that ball joint is flopping around, who knows? So if it's preventative maintenance and your ball joints aren't really that bad, then no, you don't need an alignment after you replace ball joints. Most folks, unless they're that bad, typically replace the ball joint, you put stuff back together, and as long as you haven't loosened up the eccentrics that go through your control arms or done something else that would otherwise affect the ride height of the car, you don't need an alignment after the fact. You can just replace the ball joint and go on. That's especially true with end links. If it's ball joints on both ends, they don't care. You can install them. They'll move around and flex wherever they need to be. Anything else? Okay. So I have one practical application for ball joints where I'm going to show you to replace or how to replace a ball joint. And in this case, because it is actually something we get asked about a lot, I have an upper controller. So this is from an NA, oh no, I'm sorry, this is NB, excuse me. But NAs look basically the same. They have the same style. Just again, the tapers are different. But they have the same process. I'm going to be using some pretty basic tools. Got myself a mallet with a soft face and a brass face. I also have a burp gun with a socket. I have our friendly hazard fraught press tool set with all kinds of dies. In this case, I did actually have to get a little piece of tube as well. This was just kicking around in the shop. It was the right diameter to go right over the top of my ball joint, so that way I can press it. So, if you do have this particular pressed kit, just know that you'll need to have an extra piece. If you have a fancier pressed kit than ours, then I applaud you because you probably don't have that problem. But what I'm going to do here is get all of my pieces just loosely assembled and get them fitted up here. Oops. And this helps if you if you're not necessarily doing it on the side like this, but since we're trying to showcase how everything's going, basically I've got everything in the press line up here, and I want to be able to press the ball joint up through the top of the control arm. So I'm actually pushing it from the bottom here. Make sure you've got everything lined up nicely. And then, because I'm a professional, I'm going to put on my PPE because it's good for you. It's safe. So now I'm going to use this press tool to push the ball joint out from the bottom. Just going to use my impact here and give it a few little rotations. There we go. So just like that, now you can see my press tool is pushed all the way through. So should be able to start removing parts and get this out of here. Excellent. Okay. So there's my ball joint, the old one. Again, these guys are just splined into place, kind of like wheel studs. And now, oops, my press tool sleeve got stuck in there. There we go. And that's how you do it. Pretty straightforward, especially if you have the right tools. If you have a hydraulic press, you know, like a 20-ton, 30-ton press, that makes this job really, really easy. But these guys are pretty cheap at your local Hazard Front, so I figured I'd show you on this kind of a tool. And you can probably see on the inside here, if I hold it just right, you can kind of see where the marks are from the splines. And these guys, they do press this hole, this opening open when it goes in and a little bit when it comes out. So that's again why it's so important that when you use a new replacement ball joint that gets pressed in from the top, that it has some kind of a locking ring or weld feature so that way it doesn't get popped back out again. Okay, and that's my show and tell. Do we have any more questions? Or have I answered all the ball joint questions? Did you learn more than you thought you did or would with ball joints? Again, they're pretty simple things, but basically they're very important. A lot of cars have them. Miatas use them a lot for their suspension. So hopefully this is good information for future reference, that if you're under the car, take a look at the boots, give the ball joints and the hubs a little wiggle, see if they're bad, if they need to be replaced. And if you do need any help with any of it, of course, feel free to call us, send us an email, send us a message. We'd be happy to chat and make sure you get the right parts for your application. If you like this kind of thing, give it a like. And of course, subscribe if you want to see more of this kind of stuff in the future. We do appreciate all of our subscribers. This is something that I have a lot of fun with, and I hope that you enjoy these videos too. So if you'd like to see more of this, hit that subscribe button and we'll have more content for you next week. And if you have any suggestions on what other topics you'd like us to go over for these kinds of videos, drop them down in the comments below. We love your comments and suggestions, so that way we can get a lot of input for, you know, what things are out there that maybe you don't know about. What things do you want to learn about that, you know, might have been out of your reach until you learned about them. Hopefully this has helped you. And of course, we sure appreciate your time. We will see you next week.